In this video, we're going to take a look at how you know when your battery is dead and when it's time to retire that pack. Oftentimes you'll crash and it's pretty obvious. You may end up with a cell that's punctured or scraped, a cell that's deformed, or even a pack that's caught on fire because of a crash. Sometimes you'll get lucky though, and you'll get to fly a pack right up until its useful number of cycles has been exhausted, or maybe you just left that battery charged instead of at storage for a long time. Let's take a look at a couple different ways you might know when it's time to retire that battery. The first method here is feeling sag in your flight and taking a look at the OSD. This footage is a fairly drastic example because, as we'll confirm later in the video, this pack actually has a couple of different tired cells, maybe even 3. Let's take a look at this DVR and note a couple other important things. First off, if you take a gander at the bottom left of the screen, you'll see that I have my OSD configured to show the total pack voltage. Just below that is the individual cell voltage, and note that this quad doesn't actually have separate voltage sensors per cell. It's just taking the total pack voltage, knows that's in the 6S voltage range, and divides by 6. Just below that at the bottom, because this speed controller does have a current sensor built in, I have the milliamp hours drawn so far in the flight. Now let's go ahead and talk through this flight. As you may have seen the dogs walking by while we're talking, I'm not racing here. This is just a casual flight for the dogs to chase the drone, get some exercise. We're not really pushing on the quad or beating up on the battery too bad. If you look up in the top left of the screen, you'll see my throttle value. I don't really ever push on it too hard. One other thing to note here is that the props I'm running are pretty aggressive. These are old school racecraft style 50-50 props, and they have a pretty wild crane shape. They're very amp hungry, especially at high throttle. That being said, the props are not the reason we're having such a difficult time with this battery. So you'll notice we haven't really pushed at all yet. I think I kept it under 70 so far, and we've already seen a low voltage warning a couple of times here, or a low battery warning. And I just saw there a land now warning. We're not even 20 seconds into the flight. You'll notice that the voltage was full at the start. We were at that 25 volts. Now we're already sagging down to 22 at just above hover. Granted, it's definitely sagging more when we're kind of pushing. We're doing some of these tricks and flippy floppies. But man, this thing is really struggling already. We just got a pretty constant land now, and we're just barely a minute into the flight here. As we continue flying a little bit here, you'll notice that not only is it a constant low battery, we've actually switched to a constant land now. The individual battery voltage gets very, very low. We're down in the 3 volts per cell as it's counting, when in reality what's actually happening is 1 or maybe 2 of those cells are just super low. They're down at a volt, maybe even lower, and so your total pack voltage ends up being so low that when you divide by 6, it seems like they would all be super low, down at 3 volts per cell, which is dangerously low for the battery. So we're going to come in for a landing now, and let's go figure out another way to look at this pack. So as we've landed here, we're going ahead and taking a look at this battery. Sorry about the flashing of the camera. Not really sure why that happened, but the battery itself on cell number 1, which is the battery closest to the ground side, is very, very warm. I'm not noticing a bunch of puffing. That's another obvious sign that you've got some sort of issues going on. A lot of times the electrolyte in there will end up boiling and kind of steaming up. It'll make the pack itself swell. That's not a good sign. This one doesn't seem to be doing that, but the temperature is a little uncomfortably warm. And strangely enough, it only feels like it on that ground side, the cell number 1, not on the power side, the red side there, which we would call cell number 6 in this battery. Let's go ahead and take that thing downstairs and take a look at it. So we're throwing this on the voltage checker here, and this is exactly what we were seeing. You'll notice that bottom cell there, 3.81, 3.82. That's actually cell number 1 on this meter. It starts from the bottom and goes up. And you'll also notice that cell number 5 there, 3.86, is also very low. And cell number 3 is not really looking great either, 3.88. This battery's still warm, and as we go through here, the cells are actually kind of coming up a little bit. They're starting to kind of rebound, so they're still a little elastic there. So I think it's best if we let this thing cool down and then take a look at it after it's all cooled down. So we've let this battery cool down, and we've also brought the cells down to about storage, 3.8 volts per cell. And we're going to go ahead and give it a look on the measure internal resistance mode of my charger. So first off, we're checking out the Turnigy reactor. This measure internal resistance mode is buried in the special modes. And we got cell 1 there with a 39 and cell 5 there with a 37. Pretty rough. Cell number 3 there with the 28 is not really anything to write home about either. That's not particularly impressive. One thing to note is you got to take all this stuff with a kind of a grain of salt. These numbers don't really mean anything relative to a different charger. So don't look at these numbers and say, oh, now I know what my batteries are supposed to look like because I've seen these numbers. The numbers are fairly consistent from themselves. So if you're using the same charger with a set of batteries, you can compare the batteries to each other. But if you're comparing between different chargers, no dice. This Turnigy AccuCell 6, the battery resistance test mode, is right on the main page. Let's go ahead and see what we get. And again, cell number 1 and cell number 5 are the really sad ones here. Cell 3 is not great. But if you compare it to the Turnigy reactor, those numbers are very, very different. So be consistent with which charger you're using. You can't really compare from charger to charger. Even noting that these are both Turnigys, I bet you even if we had 2 Turnigy reactors, we'd get different numbers on each of those. So something to note. Definitely an interesting and useful tool if you understand the limitations of it. For reference, I've gone ahead and plugged in a brand new China Hobby Line 1300 6S into the reactor here, and we're seeing like 5.8 on the internal resistance measurement, not 40. We also did it on the AccuCell there, and we're seeing pretty similar numbers. Everything's at 5 or less. So it seems like the chargers are actually a little bit closer if the cells are brand new. Still a discrepancy there. But yeah, that's a pretty drastic difference, a single digit, all the way up to nearly 40 on that Turnigy reactor. Another kind of fun thing that you can use here is just a portable soldering iron and your regular old battery checker. I also have in line here a current meter, but you don't necessarily need that. That's just for more visuals here. So we're about to plug in that portable soldering iron, and we'll take a look at how much current draw we get. It looks like about 4.9, maybe almost 5 amps. That's almost nothing in comparison to even a hover flight. And you'll notice we started with about 3.8 volts per cell, and now cell number 1 that I'm pointing to there and cell number 5 are really sad. That's almost 0.2, maybe that's more than 0.2 volts per cell worth of sag. That 3.66, again, cell number 3 also pretty tired. So even with this, as the iron's warmed up, we're just about 2 amps worth of draw. That battery is sagging really, really bad. We just went ahead and unplugged it, and they're definitely coming back up to that 3.8. But even under just a barely any load, there was a pretty significant sag on those cells. And again, for reference here, we'll go ahead and plug in one of the brand new China Hobby Lines. We're at about that 3.8 volts per cell, maybe a hair lower. And under load here, we're not even dropping 0.1. I think each one of those were 7.9-ish, 7.8-ish, and we're down to 7.4, 7.5. More importantly, you'll notice that all of those cells are nearly the same as each other, even under load. You're not having any of them individually drop much lower than others. And you don't need to have a portable soldering iron either. You could probably take your props off and just plug the quad into Betaflight and crank your motors up for a couple of seconds and just see if your individual cells sag something serious. Finally here, we've just got some DVR when I start to warm up and feel a little bit good on the course. These lines aren't particularly good, but this is a good testing one for, if you take a look at my throttle position, I'm regularly hitting 100%, staying up in the 90s, 80s for pretty good sections of time. We are well past a minute here, and we're finally starting to get some low battery warnings, but only for a couple of seconds. And our cell voltage is not dipping particularly low, and it recovers really quick there right after that crash. So this is what a good looking battery looks like. You shouldn't be getting these low battery warnings until late into the flight. Hopefully this helps you out, and have a good one. May all your batteries remain unpuffed and have infinite life cycles. Have a good one.